Hi class, I will be reviewing the classwork from Thursday when it was out. I'm sure you had questions about it. So for number 1 here, I'm reading, how many triangles will the next two figures in this pattern have? We notice that here there is one triangle, then it becomes two triangles, it becomes four triangles. I'm noticing right now this could be, what is it, plus 1, actually times 2, and I'm taking a guess based on the pattern that it could be like this, 8 and then 16. If we think about drawing another triangle here and adding rectangles side, well, maybe I'll draw the rectangles first, like this, and then draw it like that. My picture's not the best. We should be getting 8 and 16 and so on and so forth. My attempt at the drawing isn't the best. For number 2, can you conclude that the triangles are congruent? Explain. I'm noticing here for these first set, AZQ, so I'm going in this direction, AZK, and DRS. As I'm looking, there are some markings here and here, so angle K here should correspond with S. Nice, I have that. KA should correspond with DS. Okay, KA, K to A, D to S, good. And I should have the second side, RS, also corresponding KZ. RS, KZ. Cool. So by SAS, for A, they are congruent. So clean up this a little bit because I have to deal with the next couple problems. SDR, and JTN. Okay, I'm noticing J and angle S here and here correspond. I go over, let's see, well, it doesn't look like we have it this time. Alright, we have a right angle. We have this side and this side, which look good so far. However, right now we only have three pieces. There's no, oh wait, we do have 3 pieces. Angle, side, by AAS. They are congruent. That is one of our choices here. Noticing the procedure, I'm marking the sides, then looking at the corresponding parts. This is a T, Z, K, A, N, J, T. I'm looking Z and K, alright, they have J is not, oh, J is in the same position as K, nice. So we have those same angles. We have a third marking over here, but no third marking here. So then, not congruent. We don't have enough information here. We don't have the right angle, we don't have these 3 markings that I'm adding in, those aren't there. So we can't tell whether or not they are in fact congruent. Okay, so 2A, 2B, 2C. Let's scroll down. You had an example here going over congruent parts, or overlapping parts, common parts, more complicated diagrams. And in number 4, you kind of put this into practice. Your diagrams are getting more complicated now for you to identify congruent triangles. So name the common side in ADC, looks like this, ADC, and maybe I'll change colors, and BCD. Notice where the colors overlap. Okay, so for 3A, we have CD, a segment, is the common side. That's because that's where the blue and the green overlap. For 3B, name another pair of triangles that share a common side. Name the common side. Cool. So I'm going to try to do triangle BCD and triangle BDE. BED. I'm working on the order, so these two letters should be switched. Those parts don't correspond. BED shares segment BD. So I was looking over these two triangles that kind of make the isosceles triangle here. There are many right answers for this one, and so I'll have to check over your classwork. This is one of many. This is for 3B. One of many answers. For these two, identify their common side or angle. It's not as bad. The colors are already there to help you out. So here, segment LM, here, segment MN are common sides. Notice this third one, angle M, is a common angle. That's my symbol for angle. For these two, there's just DF. The segment is the common side. None of the angles are shared, only that middle diagonal. For this picture, number 6, I think it's only this segment. Oops. Segment XY is the common side. I don't believe any angles are shared here. Because I'm looking, right? This one and this one, those aren't common. They may be congruent, but based on the diagram, we can't tell. There are the answers for 4, 5, and 6, practicing the common sides and common angles, which you'll need later on for the proofs. As we're thinking about the different parts, for this one, we notice that first they started with a complicated diagram. And then they separated the triangles so the parts are obvious. And then you have these two resulting pictures. Because WZ and WZ are a common side, we now have 3 pieces, 2 angles, and a side in between them, which leads to the answer for number 7 being ASA. Right? Remember, it's an included side between 2 angles here. I have to apologize for the next couple, 7.5 to 13. I made a mistake here when I was creating this. Made it a bit too quickly. Here's what I intended it on being, so I won't mark you off for getting 7.5 to 13 wrong. So in this picture, I'll draw it bigger. We have this rectangle with an X in the middle. Looks like this. E is this midpoint. A, B, C is over here, D is over here. So we have these triangles, A, C ACD being congruent to BDC. BDC. Okay, so these two triangles at the bottom are congruent. So that means this side is congruent to this side. Maybe I'll change colors for this. Okay, so knowing the congruent triangles from the given, let's see, purple. Okay, so there's the purple one. To help you see it, that's BDC. Maybe an orange. There's your second one. ACD. What's the reason here? That's given from the problem. And then our goal is to try to prove this thing. Well, we know that. Let's do it in red. AC is equal to BD, that's this side and this side, so we can add in that marking. How do we know? The reason here is CPCTC. If they're congruent triangles, then all their parts are the same. Next, by vertical angles, you have this X here. AEC, let's mark it, is congruent to here, this blank. I wanted it to be BED. This is where I messed up, because really we should be proving that these two triangles here in the middle are the same. That's where I made my mistake, because this one should not be same segment. We should be looking for an angle here. This is what I have to apologize for. This one should be angle CAE is congruent to angle DBE. And I should have drawn an arrow that leads over like this. What's the reason here? It's again CPCTC. So now we have our third piece of information. Angle, angle side. It's what leaves the highlighted triangles to be the same. That's what I should have written on here. I apologize. I wrote this flowchart problem wrong. I messed up in this area, 9 and 10, which throws off your whole proof, or flowchart proof. I'm easing you into this idea of proving. We'll come back to it once we meet up again in the fall. And then we focus in on these particular segments. What color haven't I used yet? In purple. Okay, we wanted to show this side and this side are the same. Okay, CPCTC. Because now we have that the smaller triangle is kind of the bow tie. This triangle here and this triangle here are congruent. So all their parts have to be the same. That's the main problem I wanted to review. We can go through the rest of this worksheet as we redraw, separate and redraw the indicated triangles and identify their common sides. Cool. PQS. PQS. Okay, so I'm looking at it and drawing it in the same way. Q, PR. Q, P, and R. This thing is the common side. Segment PQ, common. And that's all for these two triangles. Here, as we're separating things, number 15, A, C, B, A, C, B, P, R, E. This picture looks really similar to the previous one. They probably just changed the letters. So this one, RC, actually, well, that's not the whole side of the triangle, is it? ACB, P, yeah, this one's different from before. So this one, only common angle. Only angle B here is in common. I was going to think it was one of the sides, but they're not overlapping completely. Number 16. I'm reading the letters and drawing it in the same way. J, start in the corner, go up to K, over to L, J, K, L, M, oops, M, L, up to K, and then back down. M, L, K. We have KL and KL here in common. KL is definitely a common side. No shared angles here. 17, we're filling in the reasons. So in this picture, let's mark up the different parts. T and Q are the same. Oh, they already did it for us. Like that. PQ is the same as PV. Great. And we're trying to show PQT. Maybe I'll use a different color. We're trying to show this angle. Oops, it's huge. Alright, doesn't matter. Those two things are the same. This and this reason here is given. This one's given. T PQ is the same as RPV. This one is common angle. That's the reason there. That was the new idea. When we have angle, angle, side, AAS. Let's check our diagram. Nope, it's not AAS. So those orders are off. How do I know? If I look at my picture, that's kind of messed up now. Okay, if we know that this angle is the same as itself, we have angle, side, TQP, yeah, angle, side, angle. So if I were to separate it out, which is another way for you to show it, maybe it's a bit more clear, like that, and like that. Shoot. Okay. I can draw this better. Gosh darn it. Okay, one more time. Let me try to separate it out. P, Q, T, P, Q, and T, P, V, and Q, P, V, and R. These two angles are the same. P, Q, okay, P, Q, R, V, and angle P. Oh, nope, I was wrong. It's not ASA. It is AAS. Because as I separated them, it became clear it wasn't ASA, not ASA, because the side wasn't in between the two angles, and that's what I was trying to confirm. Reading off the letters like this won't always work, so you have to go back to the diagram. Although it's a good start. And how do you know these two angles are the same? CPCTC. 18, just two more. Which triangle congruence theorem shows the triangles are congruent? Let's mark it up. And some of the pencil markings are already there. RS, UT, RT US, those are the same. We notice here you have a common side in ST, and we're looking at RST. Okay, great. Looks like it's SSS. Okay, for 18. We have 3 sides, one of them being a common side. This one, we have QD, same as UA. Angle is here. Oh, another common side. We have SAS here. And that's the big review of the worksheet from Thursday. You can check over your answers. I'll grade them soon. And the main focus was into this proof where I messed up over here in this side. I gave the wrong reason. It wasn't the same segment. It was another usage of CPCTC. That's all, class. Have a great weekend. See you again on Monday.